We are continuing in Rosen, Discrete Mathematics and its Applications, Section 1.7, Introduction to Proofs, and we are learning techniques for proving implications, such as P implies Q. We just got through discussing direct proofs, and now we're going to start a discussion of indirect proofs. The first of those will be proof by contraposition. So with the direct proof, we assume P and we prove Q in order to prove the implication. With contraposition, we're going to assume not Q and show that not P is true. And the reason we can do this is because P implies Q is logically equivalent to the contrapositive not Q implies not P. And so if we give a direct proof of not Q implies not P, we will have proven indirectly that P implies Q. So here's our first example. If when n is an integer, 3n plus 2, if 3n plus 2 is odd, then n is odd. We're going to prove that by contraposition, or the contrapositive. So 3n plus 2 odd implies n odd is logically equivalent to the contrapositive. N even implies 3n plus 2 is even. So we'll prove that contrapositive directly. In order to do that, we will first assume that n is even. Then we can apply the definition for even. N is equal to 2k for some integer k. And now we can do some math. We'll plug 2k in for n, and we'll see that 3n plus 2 is equal to 6k plus 2. And if we can factor out a 2 from that to get 2 times 3k plus 1, which we can call that 3k plus 1j because it's an integer. And we can see then that 3n plus 2 meets the definition for even 2 times j. And so we can conclude that 3n plus 2 is even when n is even. And then by the contrapositive, that when 3n plus 2, that when n is even, 3n plus 2 is even. And then by the contrapositive, that when 3n plus 2 is odd, then n will be odd. All right, let's look at another one. Here we want to prove that if n squared is odd when n is an integer, then n will be odd. So I'll write that out. N squared odd implies n odd. But we're going to prove it by contraposition. So I'm going to say that's equivalent to n even implies n squared even. And so the thing we're going to assume is that n is even. So assume n is even, then we can use the definition of even to say that n is equal to 2 times k. And now we will square it to get n squared equals 4k squared. But that can have a 2 factored out, so that n squared is equal to 2 times k squared, which is an integer. But that meets the definition for even, so n squared is even when n is even. And then because the contrapositive will also be true, that if n squared is odd, n will be odd. And that is the first indirect technique called proof by contraposition, which is effective on proofs of implications.